Welcome again to another edition of the Southwest Climate Podcast. As always, Mike Crimmins. Mike.
Hey, Zach. Monsoon halftime edition.
Monsoon halftime edition. How do you feel?
I feel humid. I feel sticky.
You feel sticky?
Yeah.
You look kind of, I don't know, angry.
I'm not. Not more so than usual.
All right. Well, I'm excited.
You are just bouncing.
I think the monsoon so far, I think we got to give it a letter grade. And if we did, I'd give it an A.
The way you were talking earlier was like an A plus, like an unwarranted A plus, like total grade inflation.
I think this monsoon season, we'll talk about this. We'll get into the details because I think there's differing opinions about the monsoon. Maybe a little frustration here, maybe a little optimism there, but
you need to articulate why you're so happy about this monsoon season.
We'll do that. So the monsoon is past its midway point. I think for the most part, we're coming at you, mid-August. And for the most part, we have another month or so of the monsoon. And I think, Mike, maybe we'll start off with a sort of regional roundup. Let's narrow in here on the Southwest. And if you look across the Southwest, for the most part, rainfall at, let's say, the Tucson Airport's been above average. Let's say the Douglas Airport, it's got to be a regional airport.
Douglas International. Thank you very much.
Douglas International. I'm looking
Douglas
at
Bisbee, I think.
I'm looking at the National Weather Service website here. So they've got it labeled as Douglas Airport. That's slightly above average. The Nogales Airport, the measuring station there at the Nogales Airport is close to average, a little bit below average. Sierra Vista.
Oof, that was nicely said. Yes.
I always default to the Spanish pronunciation of
Spanish
words.
As you should. That's what they're for.
Sierra Vista has been above average. Oracle above average. Safford Airport right around average. Wilcox slightly below average. Picacho Peak way above average. And Ajo way above average. So, in this part of the desert, it's been pretty good.
It's been a good monsoon season, except for I can't even say my backyard. It's actually been a good monsoon in my backyard, but I think I've been hanging around too many people here in Tucson who are pretty disgruntled by the activity that they've had in their backyards.
So why is that?
It didn't rain in their backyard. that was the short of it.
So maybe we should zone in then. No, before we zoom in on a particular city, I mean, let's go out and think about the state as a whole.
Yeah.
If you look at the rainfall averages across the state, Central Arizona has done pretty darn well. Phoenix has received a lot of rain.
Right.
We'll talk about that. The high country, Show Low, Flagstaff, Springerville has all experienced fairly good monsoon activity.
Yeah. So I think that the high country has largely done pretty close to average in a pretty consistent frequency of rainfall through the monsoon season. The places that really stand out in the state are like Yavapai County, parts of Maricopa County, and then western Pima, and then even up to Mojave County. So there's been this sort of central to western parts of Arizona have had very, very good monsoon season. If you go far to the northwest of Arizona, towards Navajo and Hopi, it's been very, very dry. Hopi has actually not crossed an inch total yet for the monsoon season. And just south of there, even in Winslow, they've had more rain than Hopi proper. And much of Navajo has been much drier than average as well. So as you go to far northeast, they've really missed out on the monsoon action. You go down to the low deserts towards Phoenix and then westward, southward, and northwestward. They're talking 2 times to 3 times the monsoon averages for this time of year.
And southeast Arizona's kind of been in a dry hole.
Yeah, it's not been as busy. It's not been as wet as years past, but the activity's picked up over the last couple of weeks and has started to push stuff towards near average levels. There's been a couple breaks in there, but it's been really looking, if you're in Tucson, you've been looking west and then to the northwest for all the storm activity. It's a little bit inverted from what you normally see in the season.
What do you mean by inverted?
Well, I mean, it's usually we're gloating as the storms are sort of forming in southeast Arizona. They'll make it into Tucson, and then we will send those outflows into Phoenix area, and they'll just get dust, where it's been actually the opposite. They've been getting a lot of storms forming over the high country and then being able to make it out and move into the desert locations. And so Phoenix has had runs of days where rainfall has made it to downtown, where Tucson proper has not. You're stunned.
I am stunned.
It's hard to believe.
There's a lot more nuance to it. One thing that I was trying to puzzle out, Mike, is why Phoenix, why that central Arizona has been particularly active this year. I mean, if you recall, they on average get half the amount of rainfall as we do in Tucson. Now, obviously, if you look at the totals, a lot of places around the Tucson area, has been above 4 inches. I think the airport itself is at 4 inches, a little bit above that. It's above average there. I would add as a caveat, though, that I think it's above average just because of that dollop in mid-June. Although Tucson has been wetter than Phoenix, as one would expect, Phoenix has been pretty wet. Why is that?
Yeah, we'll probably get into this, but the monsoon has been in Tucson has been showy, but not showy in the way of like blowing down neighborhoods and flooding out backyards to a large extent. I mean, but that has happened in parts of Tucson. But if you go into like the urban metro center of Tucson, it has been, I think our expectations for these knockdown events that have flooded out Tucson, like we saw last July and then the year prior, it's been inverted. And so we've seen a lot of activity towards foothills, which you would expect, towards Oro Valley, which you'd expect. Phoenix, on the other hand, will wait for just the right conditions where the storms will form in the high country, and they're waiting and primed with an unstable atmosphere, waiting for those outflows from those storms to kind of move into the Phoenix area and then hopefully trigger some event. They have not had to wait around very long or have had many breaks actually in activity. And in August alone, they had runs of 5-6 days where they were getting that same setup and storms making it into Phoenix, which is pretty unusual for them to get back to back to back kind of events.
So they're reliant though on the winds coming from the northeast.
Yeah.
For the most part.
Yeah, and it's usually outflow driven. So they had the sort of broader scale, maybe sort of backing up here and looking at the broader scale picture. So we talk a lot about the Four Corners High, right? The larger subtropical ridge, sort of the mid-level. So the atmosphere, the Four Corners High, putting us on the south side of that high has easterly flow across Arizona. And we also want to have low-level moisture advecting in from the Gulf of California. We have had that low-level moisture advecting in from the Gulf of California really consistently since the middle part of July. Just this kind of constant seep of moisture. It's just been in the soup in the low desert. And the high-pressure system has actually really swirled around the southwest and has gotten parked up over northwest of here. And even the broader ridge was actually parked up over Northern California. So like right over the heart of those fires in California, just getting totally beat up by that high pressure, those high temperatures. There's a trough, so low pressures, very unusual kind of pattern for midsummer where it was cool troughs coming in over the Great Plains in the Midwest. So we're kind of in between that. That sets up a northeast flow and a pretty good northeast flow across Arizona. That's like a great setup. If you have the storm activity forming on the Mogollon Rim, which is perfectly perpendicular to that flow, it's going to have those storms form. They're going to come down into a soupy environment. Those outflows are going to release all that instability and just generate a bunch of storms. And so we've seen the precip totals really stack up in that region. Yeah,
it was pretty impressive to watch the radar a few of those nights where you saw the big storms, the severe areas on the radar, the reds just sort of racing down from the north and this really long line of...
Exactly. Yeah, just there were squall lines, for all intents and purposes. And so well organized, good clip, good steering flow at mid levels of the atmosphere, helping to organize that outflow.
But missing Tucson.
Tucson just isn't in the best spot to really capitalize on that. We've had plenty of instability here. Interestingly enough, this instability has actually even been better in the Phoenix area than it has been here, but just not quite the right broader scale conditions to consistently have us capitalize on that.
Yeah, so let's go back because I think one of the defining characteristics, at least for me, this monsoon season is just how persistently high the precipitable water has been. I mean, it's not been record levels, but it's been
date from in certain days. Yeah, we like crest it, like we get close to it. But yeah, you're right. I mean, it's just been solid.
There's been a few breaks. Actually, if you looked at the dew point in Tucson as a measure of that, there's really just been one couple day period in mid-July where
Yeah.
the dew point temperature actually fell below a value that would favor monsoon development. It's just 2 days. For the rest, once it went above that in early July when the monsoon started, it's been persistently above that level.
Yeah, and I think that the larger scale circulation pattern has been really consistent in having the ridge to our north. And so I think that's helped sustain it. Yeah, I can see that real almost shut down on July 22nd. There's a little bit of thunderstorm activity in the high country, but overall the state was dried out. But then subsequently after that, moisture seeps back in and you start to see that storm activity really pick up. And it's towards the end of the month that you start to see some of the really big events like Phoenix. I pulled up some of the storm data from the Storm Prediction Center and just looked at some of the totals. So the total number of hail reports in July for Arizona there was 12 reports of hail. And again, this doesn't mean that there were only 12 locations, but these are reports that come in from the public by law enforcement or by the news that get logged in there. So 12 hail reports and 78 wind reports in July. And just in August alone, we've had 2 hail reports and 13 wind reports. And most of those have occurred in the Phoenix area. The biggest events and the bulk of the reports have happened in the Phoenix area, with some reports of, 3/4 inch to inch hail up near the Prescott area.
Wow.
Lots of storm damage around the Phoenix area with wind, and a couple of injuries from like falling trees and roofs being blown off of houses.
Those sound like high numbers. Do we have a climatology on that?
Well, so that was interesting. So I pulled up last year. What's your guess for last year's wind reports in July?
For Phoenix.
Total for the state.
Or for the state.
Yeah. So there were 78 wind reports in July of this year for a severe report. So the wind actually it can either be damage or if it's an actual measurement of a severe thunderstorm gust, which I think is 55 or 56. We really need to look that up and make sure that's just edited in.
I don't know. I actually want to say like there was more last year.
I know, isn't it? And so there were last year 62. So it's not that, it's a little bit higher.
Well,
there were 8 hail reports as opposed to 12. But there were 2 tornadoes reported last July in Arizona, and there haven't been any reported here on the storm database this year.
So you brought up Prescott. Prescott has been quite active.
Holy moly. Yeah.
So far it's it's close to 10 inches of rain, 9.5 inches of rain, and it's way above its average. Its average would be half of that. Yeah, and if you look across that, if you go up to Williams, which is slightly west of Flagstaff, it's 6.5 inches, which is below its average for the total season, but not by much.
Yeah.
And at this moment in time, it's way above average. Show Low's above average. The Phoenix Sky Harbor Airport is slightly above average, but we can sort of unpack Phoenix. There's quite a bit of variability around Phoenix. And Phoenix is at just 1.5 inches. But if you look at like some rain log, there's a fair number, 50% or so of the rain loggers have values above between 2 and 3 inches.
Totally.
In my mind, one of the defining characteristics so far is, again, it's just the high values of moisture. That's regional. If you look at, across the state, it's the same kind of pattern.
Yep.
What has been the role of Gulf surges in that?
Well, I think that we've had a persistent. So I think there have been discrete events where you can really see a good slug of moisture. So we're thinking about having these thunderstorm events traverse the southern Gulf of California, basically inducing a little bit of a high pressure surge, that cool air interacting with the low pressure that's with just the very hot, deep boundary layer that's in Yuma. So that pressure gradient is going to cause that moisture to slosh north, and it's going to then flow and interact with the boundary layer in southern Arizona and sort of move up in all directions. We've had a couple of discrete events that have had sort of strong. One of the ways you can measure that is looking at the sort of wind speed and dew points in Yuma proper. And if it's kind of howling out of the south and there's the high dew points, then that's kind of and then you can look at the soundings there too to see the depth of the surge, meaning is it at a couple thousand feet deep or is it lower than that? Overall, I think a couple of those discrete events, but then just sort of kind of this persistent seep of moisture moving up into southern Arizona.
And again, that's related to the position of the high pressure ridge. As it's further north, it sort of helps out the
I think right.
flow.
So it'll the high pressure ridge will help with the mid levels of the atmosphere and sort of steering direction in the shear to help move storms, and it will also help steer mid-level moisture out of the east. Mm-hmm. The Gulf surge alone is going to be really more surface-based and is going to be related to that surface pressure gradient between the southern end of the Gulf of California and then up into Arizona. And so that's been consistent in there, and there's been enough sort of mid-level flow to help sort of reset the atmosphere, pretty consistently throughout the monsoon season so far.
So it's always surprising to me when I just look at precipitable water and see the high values and values that are similar in Yuma as it is in Tucson, and for the most part, and very little rain happens in Yuma.
If you look at the soundings, right? So if we look at the measurements taken by the weather balloons that are launched, there's one here in Tucson. It's launched twice a day. There's also one up in Salt River Project, sponsors a balloon sounding. It's one up at the Flagstaff office, and then there's actually, I think it's the Marine Corps Air Station that launches one almost every hour or every couple hours in Yuma. So there's this really interesting database down in Yuma. What you'll often see there is huge amounts of instability in Yuma because it's so wet at the surface, but a really strong temperature inversion. So to actually release that energy is going to take some kind of lifting mechanism to liberate.
And the sun itself isn't...
It's usually not enough.
It's not
Even
enough.
if that's
and
really...
there's not much topography.
No, exactly, right. And so if you had a great, if you had a 10,000-foot mountain there, you may end up having enough relief there that at the top there, it would be unstable enough to actually generate some thunderstorm activity.
So it kind of needs to rely on these outflows.
Yep, absolutely. They're originating in the high country. So they're originating along the Mogollon Rim, and they're propagating, and they're...
It's just far. It's just a long distance.
And they can make it, and so we've seen that a couple of times this summer so far, and it's really kind of incredible to think that you can have this line of thunderstorms that's constantly regenerating itself on this outflow line. That the front edge of those haboobs that you see there is the front edge of a kind of a mini cold front, and that mini cold front is going to lift air along that boundary. And if there's unstable air and it's lifting it far enough above any kind of capping inversion that might exist, it's going to be able to release that convective potential.
Doesn't happen very often, though.
This year, it's happened probably more often. It's happening this year more often than it probably happened last year. I mean, again, this is where some of our colleagues work, like Chris Castro, is actually getting into the developing climatologies of events like this. It would be useful for us to even kind of look into that and see in a given year how many events, count them up, and see if they're kind of stand out. Can't say, but it certainly stands out as being unusual this year.
Okay, so you sort of alluded to another characteristic of this season that I think sort of defines it, which is that the atmospheric instability. Mike, correct me if I'm wrong, but this is my blurred vision if I'm looking across the entire monsoon season. But the convective instability has been pretty good. In other words, there's been conditions in the atmosphere that have favored convection.
Absolutely. And so having the combination of high surface dew points and a good deep amount of water, which you can then integrate into precipitable water up in the atmosphere, and also having somewhat cool mid-level temperatures, is that combination is going to give you a lot of convective available potential energy.
Otherwise known as CAPE?
CAPE, baby. That's right. Yeah, and it's interesting. I've pulled up some course. You can look at the broader pattern over the last couple of weeks has been interesting too. So the position of the Four Corners High and this trough that has, or trough pattern, having these cool troughs over the Great Plains has actually allowed some of that cool air in the mid-levels to sneak underneath the Four Corners High towards us. So that has actually helped maintain a cooler upper levels. And if you have really moist environment at the surface and really cool upper levels, you're going to generate a whole lot of CAPE. And so I think that's an interesting part of this monsoon season so far, is to see these mid-level temperatures. We're thinking about the temperature at about 500 millibars, or a couple kilometers up. About 6 kilometers up was about 500 millibars. We're looking at one of the soundings. No, that is Oklahoma's sounding there. What do you got that? Give me an Arizona one. Give me Tucson. Okay, so what is that? What's 500 millibars with the kilometers? That's about 6. It's a little less than 6 kilometers high. So mid-levels of the atmosphere. Having an easterly flow at 500 millibars and have that 500 millibar temperature be on the coolish side. You can kind of get down to like 7 below 0 Celsius. And if it gets warmer than that, then you're starting to look at that whole shrinking envelope of convectible available potential energy.
These values, the conditions, the convective potential, day in and day out, has been there for monsoon generation here in Tucson. So you've had that instability. Mm-hmm. You've had that, as you mentioned, you've had the sort of high water content. This is where I think the monsoon, you can kind of look at it in two different ways this year. On the one hand, a lot of the metrics that I read off in the beginning sort of suggest like, yeah, it's been active and it's been there. And, Phoenix has obviously done really well. And that's sort of one way to look at it. But on the other way, I kind of feel like we missed out on what could have been just an epic monsoon season so far. I mean, I felt like the precipitable water has been there, the convection potential has been there. Like what's been missing for us to come in at another July of last year, let's say. I mean, you sort of alluded to this where you said some people are going to be grumpy.
Right. I mean, it's one of these things that I've become so crazy greedy about what I want to have happen during my monsoon season that it is actually completely unattainable, right? What I want to have happen is I want it to rain either every day or every other day, but I want it to do it during a time period where I can enjoy the storm. So this has been an interesting thing about the monsoon so we were talking about MIMBY, monsoon in my backyard, is
that's our new index.
That's our new index. The MIMBY index is that.
Well, a high value would equate to a positive, a good monsoon.
I think a good like a smiley face emoji or something like that. I think it's all scaled down emojis.
Thumbs
that's
up
right.
and a beer.
Double thumbs up.
Okay, high NIMBY values.
High MIMBY. Thank you very much. MIMBY. I want it to happen during a time of day that I can enjoy it. So we've actually done really well with monsoon total precipitation at my house, but we've had a couple of overnight events where I didn't get to enjoy it. Right?
I think we should qualify that a little bit, because if you're thinking like right after work, that's probably a bad time. Because
it's a great time. I'm at home,
unless you're driving.
Okay, fair enough. See, that's the thing is that if everybody's driving home at different times, we got to space all these storms out, got to time them right, got to get them, to
okay, I diverged.
Okay,
I like where you're going with this.
Okay, so total wise, I'm doing really well, like above average. I live on the east side of Tucson. We have benefited from a couple of these kind of random storms that have occurred on this good after sunset convective available potential energy. So it's still there, just waiting to be released by an outflow, right? That would come off of one of the storms in the mountains. So storms gotten going later. The outflows finally sort of make it in, and you start to get a storm flow forming off an outflow. And then there you go. So the middle part of Tucson, which has in the past couple of years had absolutely epic, where they were the wettest parts of town, and any part of Tucson have had the inversion of that, where it's been very, very slow in the middle part of town. Storms very frequently occurring all across Tucson over this monsoon season, but everybody looking at their neighbor, and their neighbor was getting precipitation. So it's one of these things that this monsoon has not been a bust, but it hasn't been overwhelmingly in Tucson. Everybody's like all on equal footing for getting just washed out.
Yeah, so let me put some numbers to that. If you look at like north of Tucson, like the Oro Valley-ish, 2 to 3 times more rain on average than sort of central Tucson. Mm-hmm. And also as you go further east out to Tanque Verde, it's kind of the same story. So it is roughly around 2 inches, 2.5 inches around sort of central Tucson University, and 4 to 6 out on the fringes.
And the interesting thing is that you can go to these different parts of town, and they're all different combinations of storms. So like getting to the same total of like 4 or 5 inches, if you go to different quarters of town, it's a different assemblage of days that got people to that totals.
But I think that like you hit on the point. I mean, I too feel like the monsoon makes you greedy in the sense that it's almost like boundless potential. And even when it's a good season, it still feels a little bit like it let you down. Like think about last year. Last year, so the first July was amazing. And then part of our perception is, oh, well, it didn't continue. And, August and September didn't measure up to July, and therefore it sort of let you down. So there's always a little bit of like building you up and letting you down at the same time.
Oh, it's true. I mean, and if we're comparing it to last year, there's that comparison of like how epic it was through Tucson with some of those events, but those are very localized. It was like, remember our sort of epic couple of weeks in Tucson last July is the same thing that Phoenix is getting right now, right? It's like almost the same kind of pattern of these sort of we call rim shot storms, and they favored us last year, and now it's shifted up north and it's favoring them. This is such a better monsoon season overall for the state than so far. I mean, through mid-August, I was looking at some of the stuff, the data from last year, and the monsoon pattern had already retreated by the beginning of August last year. We're still in the thick of it, and we're still getting very frequent events across much of the state into the middle of August right now, which is good. And again, I don't want to forget that it's not everywhere. The far northeast part of the state, Hopi and Navajo, are not having a good monsoon at all. The urban centers are. Far southeast has just started to kind of pick up into the action. And then, New Mexico has had a really different season even from us, which is, again, kind of par for the course.
New Mexico's season has kind of fizzled out a little bit in the last few weeks, it seems like.
It has slowed down. I mean, they had really, they had gotten some of that same activity we had, and right at the beginning of the monsoon season, right around the 15th, had a couple of good runs in the middle part of the month, and it has largely slowed down. And you see this sort of, and again, I think it's largely related to, I keep talking about that trough of low pressure and some of these cool troughs running into the Great Plains. There's a bit of a drying signal that would come in, and far southeast Arizona got entrained in some of this dry air.
There's a pretty strong moisture gradient, precipitable water, the amount of moisture in the atmosphere as you go west to east. So as you go from, let's say, southeast Arizona into New Mexico, it changes quite a bit. If you look at it so far over the entire monsoon season, and it's not been as high the further east you've gone into New Mexico.
So, and again, remember, precipitable water, it is related to elevation. So the lower the elevation, the more that an area can have precipitable water, just because the column is bigger. So you can't have the same amount of precipitable water as you go up in elevation. So there's going to be that gradient. And so as you get into far eastern New Mexico, and you get onto Texas, you're into that Gulf of Mexico moisture. But again, that circulation pattern has not been favorable for running up a lot of low-level moisture out of the Gulf of Mexico. And the Gulf has been fairly quiet, tropical-wise as well. So there's been a bit of that Thankfully. Gradient. Yeah, right. I mean,
in comparison to last year.
That's right. And it's interesting that I was kind of thinking that we might see more Gulf of Mexico activity. And even as the monsoon season sort of moves into August, we might get some tropical disturbances that come up out of the Gulf and can make it all the way across underneath the subtropical ridge towards us. But this pattern has not been favorable for that.
Well, I think the sea surface temperatures in the Gulf have been below average.
Is it really?
Yeah.
Oh, wow.
And
okay.
I think that's part of the reason why recently, a week ago, the Hurricane Center
that's been that's interesting.
Lowered its expectation of
okay.
Tropical storms and hurricanes.
Yeah, overall
downgraded it from
whole
normal
basin,
to below
right?
normal. Yeah, in fact, to date, I believe there's only been 4 named storms and 0 major hurricanes. Mm-hmm. Obviously, that's a good thing in comparison to the Marias and I'm forgetting their names now, but the cool sea surface temperatures are aiding the lack of...
Yeah, isn't that interesting? Yeah. That really is pretty different than last year, for sure.
But going back to the Southwest, we do get flow from the east aloft, and if it's drier over there, has that at all sort of interacted with Southeast Arizona and suppressed activity?
There's a little bit. There's been a couple of days, and again, the overall pattern, this is the whole thing about trying to boil the monsoon season down to the 3 things that have made it what it is, right? And it's, if you watch, and as you and I read,
I think we named 2 of them already.
Well, we did. We did. I think that from a client, we're trying to take this sort of climate, average it all down, boil it all down to a couple of main factors. But if you read like the Arizona WRF blog by Mike Luthold or Bob Maddox's blog, you really start to see the the subtleties of the daily aspects and how they come into play. But tracking that from day to day, there were a couple of days where dry air was moving in from the east, and that would shut down southeast Arizona. But it wouldn't make it far, and maybe make it to Tucson proper. But then if you went to the low desert to the northwest of here, the Gulf surge moisture was still in place. So you get this kind of gradient across southeast Arizona.
It is hard to try to describe the monsoon because there's all of these, spatially, there's all of these different factors that play a role. Some of them are occurring sort of at a regional level. I mean, when you look at the moisture content, like those patterns are similar if you go to Phoenix to Tucson to Flagstaff, for example. They all have the same pattern. But then it's like on a daily level, there's a number of these factors from changes in the thermodynamics or the atmospheric temperature profile, which affects the thermodynamics, to what you just mentioned, the drier air evecting in this one place. And there's a whole bunch of these things that can actually make or break a day, even when the large regional scale features are conducive.
Reading these blogs, following the forecast discussions, looking at the charts every day, is you get this sense of how subtle like you get this issue where there's a cluster of thunderstorms the previous day, and they generate, they turn into a large scale convective complex, right? And so if they're big enough and organized enough, they can actually generate their own little vortex. Is it vortex or vortice? It's one of those things. That little subtle circulation can turn into a weather maker for the next day, right? And it's hard to even detect on a weather map because it's in between balloon soundings that get initialize the global model. So the flow and the topography, the flow is so weak and the topography is such a driving force out here that you get these really subtle things that the models have to get exactly right to get the forecast right for 6 to 12 hours later. So it's just pretty amazing.
So two thoughts on that. One is, on the one hand, I am incredibly impressed that the models can do the job that they do.
It's amazing.
I mean, and often amazing. They're not quite right? Yeah. But I think that they're not quite right is not a criticism at all.
No, a lot of it is it's initialization. It's like getting everything right at the very first step of the model is absolutely critical to keep it from sort of flying off. And so we have enough trouble just knowing in this very moment of what is going on in every spot. So it's like an observational issue to make sure that we have all the data to get the model to step forward. The physics are all really good, but it's like getting the model to step off on the right first foot.
Right, and it's not just the data around here as well. I mean, you have to actually piece together data from
Mexico.
Yeah, Mexico.
Yeah, they have to have
and New Mexico and Texas. I mean, you have to look. Yeah, we're hyper focused in on a particular region, and we need to nail as small of detail as we can because the monsoon itself is a really small feature.
Yep.
But yet you actually have to look at much broader areas to really understand that.
The one thing that I've thought about this for a long time, but it was striking to me this summer in particular was that we still only are able to sample the atmosphere through a direct way of using an instrument package and putting it on a balloon and letting it go up into the atmosphere. There's no other technology. When I was in
it's so cool though.
It's so cool, but it's so interesting because when I was this was like 20 some years ago when I was an undergrad in an atmospheric science department, there were grad students I remember working on projects where they're trying to use lasers to point straight up and sample the atmosphere. None of that has really panned out. So there's no other way to
Why can't they do it on planes?
Well, they do. So a lot of data is now being collected by passenger
aviation
aircraft. So there's a whole data collection and ingesting and assimilation of that data that actually goes into the models. But it's opportunistic. I'm really excited to think about, and I wonder what the next technology is how are we able, some of these days you really wanted to know what the balloon sounding would be in the middle of the afternoon or late in the morning and again in the middle of the afternoon and then a little bit later. You wanted more information than what happened at the early morning sounding and then what happened after the storms actually occurred. And so there are like atmospheric profilers where they can use sound waves, but none of them actually give us the resolution that the actual physical balloon measurement actually does.
It's actually surprising when you look at a map of the U.S. and you look at the locations that
right.
radiosondes are flown in. It's like there's not that many. There's there's 4, I guess, in Arizona, right? So there's Tucson, Phoenix, Flagstaff, and then Yuma.
So that's it. So there's the Salt River Project one is the one for Phoenix.
Oh, okay.
And that is newish. Like, I don't think that's a long-term station. I think that Flagstaff and Yuma were the long-term stations, and then the one in Yuma isn't. I think it's for other purposes. I think it's from the Marine Corps Air Station, but I'm not. Totally
And these are released twice a day.
Twice a day, yeah.
And this data forms the backbone of the models.
Oh my gosh, yeah. And it's if you read Mike Luthold's, if it's not there, we don't know what's happening. There's one in Wymus that is released, and that's super critical because we need to know south of here what's happening in all levels of the atmosphere, and then moisture-wise too, to sort of help understand the Gulf surges.
I guess I should go back and say, there's not a lot of these. I mean, I'll just do a quick summation here. There's probably 60 or 70 across the U.S.
Mm-hmm.
But that being said, it's also not like the atmosphere changes over a short distance. So there is a lot of sort of spatial cohesion.
That varies by level.
And it would probably vary by the topography.
Absolutely. Yeah.
So in the West, you probably need more denser.
Lower levels are going to be highly variable, and they're going to smooth out as you get upper levels. The spatial is one thing, but the temporal is really the big thing that could be the future if we can figure out some way of getting more frequent sampling of the atmosphere.
So related to this, the other thing that was interesting to me is just looking at this balloon data and looking at the wind profiles through the atmosphere. And we've talked about this before, Mike, about how important winds are to driving storms off the mountains or helping to propagate storms. And also, like, just their variability within the atmosphere can blow the tops of the clouds one direction that either helps enhance activity or actually works against it and suppresses it.
Yeah.
And that can be on a daily basis, like, pretty nuanced and variable.
So there was this reminds me of a day. It was a couple weeks ago here in Tucson, and it was one of those days where everything was lining up. It looked great. The profile of the wind looked pretty good. It wasn't great, and it was gonna be an issue if one thing happened in particular. But the instability was there, and we had good sun in the morning. So this one tiny little storm forms in Mammoth, which is on the north side of the Catalinas, north of Tucson here. And this tiny storm sent out an anvil over Tucson. And it was such a weight, and it was like closing the blinds over Tucson, and that was it.
And that's important because those clouds would shade the ground, would prevent the heating up, and really suppress that lift that's needed to drive convection.
Right, you're going to want to have that. You're going to end up having a situation where there was most likely some kind of capping inversion, and it was just going to make it so much harder for any storm to form in that environment.
Has there been anything interesting about the winds that might have contributed to where we are?
No, I don't think so. I think that the mid-level flow out of the Northeast, especially across the central part of the state, has been a little bit stronger than average, which has helped propagate those storms in the low desert. I think it's been a little less helpful down here and has varied from day to day as the Four Corners Ridge has sort of wandered around a little bit, especially in the last couple of days. So no, I mean, it's one of those things that it's so subtle in those mid levels of the atmosphere and at the upper levels that it has really changed from day to day. But I think largely that stronger northeast flow has helped the central part of the state in conjunction with having all of that moisture down in the low deserts.
All right. Okay, so moving forward, we're more than halfway done.
Mm-hmm.
We're, on the one hand, we're only slightly more than halfway done. So there's a lot left.
It's like running out the clock sort of thing here.
Yeah,
our clock goes until September 30th by official definition.
If you look at the cumulative precipitation, really there's a break in slope at about September 15th.
You're totally right. Yeah, and it's probably even it slows down even a little bit as you get into August too. It's definitely steepest on that sort of July 15th to August 15th.
That being said, when you look at August 15th through September 15th for Tucson, on average there is 1.5 inches. Am I eyeballing this correctly?
I think so, yeah.
And maybe if you extend it out to September 30th, who knows if there'll be a tropical storm that gives us an assist at the end of September or whatnot, even maybe during the monsoon season or sort of at its end. Maybe 2 inches. I mean, I'm just looking at Tucson's coming in right now at 4.73 as of mid-August. Average 6. You think
we're going to make it?
I think actually, and I hate to say this, but you actually might be spot on. If climatology for the next month
I thought I said out. Like a 7 and...
I think I have 125% of average.
You did?
No, I think you did.
I think I did.
Yeah. I think you're going to be.
Yeah, I think I'm in trouble.
Oh, wait, you think you're in trouble?
I actually do.
I think you're going to nail this on.
See, this is okay. Now this is where it gets emotional, right? Is that I watched 2 of these storms in the south end of Tucson the last couple of nights, like about a mile from the airport, and they could have over those 2 nights probably could have gotten an extra 3 inches at the airport, and I would be sailing to victory as we go now, but just by happenstance, there were just about a mile south of the airport.
Well, also,
it's like that whole thing of like unrealized potential right there.
Well, I'm just averaging, using the climatology as average. I mean, we don't even have to talk about the inch that you gained in June. Which,
take it. I'm not giving that back.
Which you should totally give back if you had.
But I'm not. I'm not giving that back.
If you were a real climatologist.
Take the climatology.
If you were real.
Yeah, because that was way above climatology. That is for sure for June 15th.
That being said, I just don't think the amount of moisture can persist like it's been. I mean, and basically I'm like regressing to the mean, which I don't even know what the mean would be on the precipitable water. But we are actually now on the descending limb.
You're absolutely right. I mean, you're looking at those dew point plots, and you'll start to see them sort of sag. And it's Mike's blog noted that, and you see this in some of the sounding data, is that we've already started to see the very upper levels of the atmosphere switch back around to the west. So it's that progression north we see in the transition into June. We're already on the reverse transition back out, which is
I think you're doomed.
Well,
I'm
saying
changing
okay,
it.
but this is
I got another argument.
Okay,
against
so this
it.
this is third period play. Is that your game completely changes now? Like how you get precip has got to totally change. And so I bet we have a couple of like 1 or 2 normal kind of high precipitable water days, good convection, outflow driven stuff. Then what has to happen is you start to put in the other string of players into this, and there are different skill sets. You start to now have tropical storms. Like that's got to become a player for us to get any precip later in the season. And it's the same kind of transition event that's kicked the season off, the June 15th. The total gimme that I got here on the June 15th total down here is the way we would get the precip on the way out.
Would you think, though, in later in the year, I mean, that the storms that do come are of higher quantity or less quantity?
They're just higher quality. They're just in general.
But in terms of intensity, like
I don't know. They can be.
So there'd be no change in, like, let's say, the average amount per storm?
They can be more dynamic in the sense that these transition type events are actually going to have like upper level support, like a low pressure system, what we call like baroclinicity, where they actually have
upper level support, so like suspenders?
Totally. That's like lederhosen. It totally threw me off here.
Sorry.
Is thinking about more dynamic things rather than relying completely on thermodynamics, that you have both thermodynamics and some kind of lifting mechanism. So remember that event that we had in June? It was a combo of really good, soupy, very unusually wet air for middle of June at the low levels, plus a little bit of upper level support that really helped squeeze out some extra precip in certain locations.
Well, the reason I was asking you that question is because so far in Tucson, we've had 20 days of rain, which on average, we get 25.
Yeah.
Right. So about 25% of the days we get rain.
Yeah.
Right. So if my argument before was just looking at climatology. You're going to come in at, like 120% of average, 125% of average, exactly what you said. But if you look at the number of days, maybe we only have 5 left.
On average, right.
And the average intensity is 1/4 of an inch.
I love how you're using climatology against me now.
Now
this
I'm using it
great.
against you. So if we were to do that, there's only 1.25 inches remaining in the tank.
Why are you doing all this math to prove your point here?
And if that's the case, then interestingly, if we got 1.5 inches, we would be right on climatology for this monsoon season. Using climatology to argue for climatology.
And I chose what?
You chose
25% above climo. What was I thinking?
I think it.
I don't know. I have a tough road. What did you do? You were under, right?
I was under. I was like, I don't know. I can't remember. 75%, 80%, somewhere.
Well, if it stops and doesn't.
So it would actually have to stop for me to do well, unless I can argue convincingly, which I think I can, that we should discount the 0.9 inches of rain that fell on June 15th.
I think could be some international commission we could bring this in front of and have this.
Okay, so it remains to be seen, what Tucson will ultimately come in. Mike, you have what do you think?
I said 125. I have to stick to my guns now. I think it's going to be a tough road, but anything's possible. We still have that above average East Pacific tropical storm forecast. It's been busy.
Has it been busy? We had John a week ago.
I remember Hector. Hector caused some trouble out in the Mid-Pacific.
John was tropical storm. Did it actually become a hurricane?
Don't know.
Yeah. But nonetheless, it had a trajectory that created a Gulf surge. Hector, I don't think did.
No, I think Hector was too far out. But as you get further into August and we get into September, we start to see the ridge start to sag back to the south. And so we get more into the westerlies. The westerlies are going to be that transition pattern that could drag that moisture up here.
Right. And I guess the thing that favors maybe elevated activity in the East Pacific is on the horizon, the forecast for an El Nino event, a weak El Nino event. People are bullish on it. The models are bullish on it. It's looking very unlikely that it would be a La Nina. I think that's what we could say with fairly good certainty.
That's great.
I mean, the spread
super useful, but
the
totally
spread
true.
Of the spread of the models is still anywhere from neutral to
0% chance of it being sunny this evening. That's kind of where I'm going.
But I guess the only point that I was going to make is that El Niños do bring enhanced chances of activity in the East Pacific.
So there's warm water and enhanced precipitable water across most of the East Pacific, right? And so I think that's definitely a benefit. And California, you see San Diego actually broke their all-time record warm sea surface temperature right off the coast there. So there's warm water to be had for some of these tropical storms. It's now going to be a matter of will they get steered up towards us later this season.
Any parting shots? What do you think? I mean,
I don't know. It's game time. I think this is not over. I'm gonna win. I feel it.
We still have another month. I mean, I've been pretty happy.
It's so funny. You had such a pessimistic, and you're still really happy about it.
Also, I was thinking about it on the way in today. It's like we're so hyper focused on rain as the metric. I mean, last night it didn't rain at my house, but the lightning show was incredible.
It was. I give you that. I'm so struck by your it's fine. It's totally okay if it doesn't rain at my house. Like, what is wrong with you?
Well, I'm not a gardener. Like, I don't have rainwater harvesting.
You should get in rainwater harvesting. That'll turn you into a little mini water manager there.
Yeah. If I had more stake in the game, probably
get a stake, man. Come on. You're such a spectator of this monsoon season here.
Also, I mean the sunsets.
Yeah, they've been fantastic.
And the cloud formations, from an aesthetic perspective, it's been
fantastic. Yeah. I mean, and again, right. I think that's such a good point, except I will not yield on this. It needs to rain in everybody's backyard, epically at least a couple times this season for anybody to be happy. But we have not had a 2-week break of just no clouds building. It's been persistent.
Yeah. What's the affect of the monsoon on people? If you had to guess,
it's
we need to do some science.
I agree, and it's psychology more than anything. It's this.
Do you think it makes people happy, angry? What kind of emotions?
I think it makes them crazy. I think
June makes them crazy.
Oh no, I think that's
the sun.
Yeah, that's a different kind of crazy. But this is a crazy too much sugar kind of crazy. like where you're like, why isn't it raining at my house? Oh, look at that awesome thunderstorm, but why isn't it over here? Oh, I'm so glad that's raining. And it's a mix of crazy emotions here.
Yeah, it'd be interesting to see how this affects people.
I think what it does is it divides. I will say, hey, how much rain did you get? And then you say, that was such a terrible storm. I only got a quarter. And I go, should I tell him I got an inch and a quarter, or should I lie to him to make him feel better? So it's really weird, sort of neighborhood to neighborhood psychology that emerges with this.
Yeah, well, there's some good science to be had.
That's true.
All right. Well, I think that's it, Mike.
That's it. Happy monsoon, everybody.
Yeah, happy monsoon. And I guess our next episode will be the monsoon recap. All right. We'll do the monsoon recap on the next edition. So hope y'all tune in again. Thanks again.
The Southwest Climate Podcast is a production of CLIMAS, which is part of NOAA's Regional Integrated Science and Assessment Program and is housed at the University of Arizona Institute of the Environment. Mike Crimmins is a principal investigator with CLIMAS, a professor of soil, water, and environmental science in the College of Agriculture and Life Sciences, and climate extension specialist with the University of Arizona Cooperative Extension. Zack Guido is a research scientist with the Institute of the Environment and UA program manager of the International Research and Applications Program. The podcast is edited and produced by Ben McMahon, research, outreach, and assessment specialist with CLIMAS.
Wrap it up, and I collect my.
What do
I win? What am I going to win again? I don't write this down. Okay.
I never write it down because I think my record against you is pretty poor.
I think it is. Let's keep it going.